Today we are going to look at how to perform a regression analysis in Minitab. So, as usual, when you open your Minitab window, you need to load in your data, and so we'll either go to File or we come to this folder box here. So let me go to File so that we get used to going to the place where you can find a lot of things. So click on File and then you click on data. We want to open data actually, and so you look through and find your data. So I'm going to use this as an example, Northern Region Pest Control Study. So this is more like a study that is done. The fictitious data actually is not real data. Okay, that mimics an actual study. So right now, this is the first window that you see when you're trying to open your CSV file in Minitab. So I'm gonna leave these default as is. I won't go through how to change the value labels and stuff again. We have done a lot on that already. So with this data set, we just want to study how do we perform a regression analysis using this one. So here you have a categorical variable, you have replication variable. We want to be needing this in this analysis. We have yields, we have moisture content, and we have average temperature. Now temperature and moisture content are actually numeric, and then pest control is categorical. So I'm going to combine these two in this analysis so that I will explain what is happening after you get your results. So we are going to go to statistics, then we move down to regression, and again regression, and use this fit regression analysis. So you can always pause the video to go through the steps again. Okay, so I click on this fit regression analysis and this dialog box comes. So in here I have these values here. You can see that my cursor is blinking inside here. You would realize that I had many variables. One of them is not here. So we have C2 to C5, but C1 is not there. That is because this regression is not expecting you to have a category like names in your response variable. So your response variable is actually your dependent variable, and so you don't expect it to be letters A, B, C, D and stuff. Okay, so that is why you don't see that. So any other variable that is numeric, you'll find it there. Now we want to see we want to regress yields on the others. So I'm going to pick the yield and put it right here. So as I said before, when you click inside this box, it means that whatever you select here will be coming to that box. And so I click on yield and come down here, and then I click on select. It moves the yield variable there. Now that is all we need to do here. Okay, then we move into the continuous predictor box, and this continuous predictors is your independent variables that are numeric. So I showed you the moisture content and temperature, they are numeric, so they can come in here. So I would bring them here. So, and again I showed you how to select multiple variables without having to send them one after the other, one by one. So right now one is selected. I hold my control key and I click on the second one. All of them are selected. Then I can say select to send them inside the box. I click to the categorical variable, and now you can see that pest control is available for me to choose, and so I put it right there. Okay, so now I have all the variables that I need in my module, and I now have to come here and then check and see in all these tabs that you buttons that you are seeing here. Maybe I need to do something, maybe I don't have to do anything. So I'm going to click on this one, and I see that okay, so the times in the model are this. I don't need any interaction, and so I don't think there is nothing here I need to change or add. You can see at the bottom here it says include the constant term in the model. So if you ignore this by unselecting it, you won't have a constant. Okay, but if you check this one, then you will have a constant in your model. And regression analysis, you would want to have a constant in your model. Now, areas where you cannot have constant, it's areas where if there is no independent variable, there can be a dependent variable. That is where you don't see this to be necessary. But for this, let's go on with our constant in the model. We go to the options, and the options is saying there is weights. Now you see there are surveys that they do. Some of the surveys that they do, they actually have weights for each of the variables. Okay, so if your data has weights in calculated for you, or you need to calculate the weights, you will have to put it in a variable and put it right here as your weight. But here we don't have any weights attached to it. If the data, your dependent variable yield is not normally distributed, you would want to do some kind of transformation. And that is what you're seeing down here as the box cost transformation. So I'm saying there is no transformation down to the yield. If you want optimal lambda, you would say, okay, I'm transforming it using optimal lambda, or I'm transforming it using lambda equals 0. That is a natural log, and then this one. So whichever way you want to transform it, you go ahead and do the transformation. Only if your yield variable, that is your dependent variable, is not normally distributed. So that is one of the assumptions of regression analysis that you have to take good, a critical look at when you're doing the analysis to make sure that your dependent variable is normally distributed. Okay, there are other ones. So as and when they come up, we would talk about them. So sum of squares, what is we are using type 3 adjusted sum of squares. Okay, so these I won't explain them in this video. Okay, so go ahead and say okay. Now we go to the coding if there is any coding that you need to specify, but then we don't have any. So in your categorical variable, this being selected biological being selected means that you want biological to be the base or the reference level. And so when you run your regression analysis, you will not actually see biological there. When the rest of the categories is 0, whatever value that is left for your yield is attributable to the biological. Okay, so do not standardize. So I'm going to leave these defaults as they are, and then I go to stepwise. So stepwise, the method is none. It means that it's just going to go in as is, and then it's going to calculate everything, whether they're significant or they are not significant. Just let them be inside there. Okay, and show me those that are significant and those that are not significant. So if I click here and say, let me take one of these, I want to go to the stepwise yet forward selection. So forward selection means alpha to enter. At what significance should you allow something to enter? So it's just like a job interview. You go and they are looking at your CVs at first glance to say, okay, if you did this particular course, agriculture, then you are qualified to apply for the job, and so they allow you to go in and then sit for the interview. If you come with an accountancy certificate already, we're not looking for accountants. We are looking for agricultural extension officers or something else. Okay, and so we don't want you are already out before you enter into the interview room. So those one, that is what this is indirectly telling us that. Okay, before any of you will go inside, I'll have to test you. That is the forward selection. If you satisfy this, then you go in, otherwise you don't. Now if we go to the backward, means that okay, push all of them inside as is, and then when all of them are inside, start testing them to see if you qualify. Then you stay there. If you don't qualify, you come out. That is the backward elimination. Okay, now stepwise means that you have to test both of them. Test as they go in and test as they are inside the model. So both in and out. and this is considered as the stepwise. So it actually tests they are going in and they are coming out and gives you the model of best fit. Okay, so I'm not going to do none of these because I need all the results to show you what I need to show you. So I'll leave the default as is and go on. So this validation is not something that we have learned in this course, and so this is another video that we can make of, but I can show you what is in there. Okay, so validation methods. Now you can see, and say machine learning, they do a lot of validation and stuff there, and so you might want to go ahead and validate your model. You can choose between one of these two. There are other methods, but unfortunately it's not in Minitab, so just these two methods that you can find. So again, I'm gonna cancel this and let the defaults go. Okay, so graphs, what kind of graphs do we want? So these are different graphs that you can do, or you can plot. So you can plot the Pareto. So I'm just gonna choose these plots as they are given us, and then I'm gonna plot all these four in one so that you don't see them differently. Just put all of them in one. Do you want to plot this? So whichever one that you want, you choose. So I'm just going to leave that there. And then your results. Do you want a simple results? No, I want an extended table so that I can see a lot more things than the sample table can show me. And then I come here, full coefficient set. I want to see a lot of things. Okay, not all of them that we're going to have to see, but I'm just selecting them all so that we'll see exactly what they look like in full. Okay, so only for, okay, don't worry about that yet, and leave this. Alright, so most of the results we're not going to need them as is in this, but I just want to show you what we're going to have get. If you have some things that you need to store, like the fit, if you want to store the fit as a variable, you are free to do that. Any of them that you want to store, you can just go ahead and store, but I'm not going to choose any of them. Okay, so I have finished doing whatever I need to do in this box, and so I can say okay. So patiently wait, and we have this coming up. Categorical predictor coding. So you have 0 and 1. Okay, and the 0 and 1 is referring to the presence or absence of the categorical variable. And I told you already that biological was selected as being the base reference, and so you won't see that. Now this is just a description, okay, of the variables that you put inside. So biological, chemical, and then IPM, their yield, and the various things. So that is not of importance now. This is what we want to see. This is the coefficient table, and then we ask that it add a constant, and there is a constant here. So in the absence of moisture, in the absence of temperature, in the absence of pest control, we expect the yield to be around 45.36 units, whatever units that we use in measuring. And this is the standard error of the coefficient here with this 95% confidence interval. Now if you want to see whether this is significant, it is not different from 0, then we look at here. So it means that the constant is actually, the value here is not different from 0, and so it is significant. When you look at moisture content, the coefficient is negative 0.07. So what this tells us is that for every 1 unit increase in moisture content, we expect the yield to reduce by this quantity. Okay, however, this is not significant, and what we mean by not significant and regression is that this coefficient we are seeing, whether it's increase helping or not helping the yield, it's actually equal to 0 statistically, and so it doesn't do anything to the yield. Okay, whether you increase or you decrease, it doesn't do anything. No matter the value here, it doesn't do anything to the yield. That is just what the non-significance of this means. If you look at average temperature, we have the p-value to also be greater than 0.05, and so it is not significant. However, we can explain that for every 1 unit increase in average temperature, we are expecting the yield to increase by this units. Okay, so if assuming it was significant, that is what we would say, and we should expect that to happen when we increase the temperature by a single unit. Now, when we come to the categorical variable, interpretations limit is different from that of the continuous. Now, what I mean by that is that we used chemical and biological as the base, and so chemical and IPM is evaluated or measured against this. It is compared to biological. So for chemical and biological, the comparison would be this. So biological minus chemical giving us negative, we expect that chemical should, the coefficient for chemical should be greater than that of biological to get a negative. The same way with IPM, the coefficient here, value here should be greater than that of biological to get you this. Now again, if we come to the p-values, they are both not significant, and that is to tell us that chemical is not different from biological and IPM is not different from chemical. However, we are not able to compare chemical and IPM in this particular regression table because you only have one base that is used to as the base for comparison. If you want to do that, then you have to run another one and choose either chemical or IPM as the base, and so you can see that comparison as well. So this is all about the coefficients table. Now we come to the model itself. Now the model itself, I'll be looking at this arrow square here. So we have multiply this by 100 and you have 48%. Okay. Oh, okay, it's already multiplied, so it's in percentage. So it is not actually having much contribution. So if you look at it, you can see that this one is less than 1%, and 1% is not a good thing to think about. Okay, so your model doesn't do anything at all. It doesn't explain any of the variations in yields given these variables that we have here. And so there are plenty other variables that we could have thought about to have an influence on the yield, which we didn't consider in this model. But these that we have considered will not be able to. We cannot use them in the model to say that they influence in any way. Okay. Now, if we had a simplified model, a reduced model, or another model, and we want to compare the models, we would use the AICs or the BICs to do that comparison. But this is just a single variable, a single model, and so these two here, they are not actually doing anything for us here, unless you have another model you want to compare with. Okay, so the ANOVA table is more like a simplified version of the regression table that is just giving you the regression model and the individual variables and their significance. Okay, fits and diagnostics for unusual behaviors. So you saw that we indicated some statistics, some diagnostic tests to be done, and that is why you are seeing all these things come up. Now let me move down to the graphs that we plotted here, and you can see them here. All right, so the plots don't look too good and they don't look too bad as well. And so if this wasn't a controlled trial but a field study, I think would have welcome this results or this data, because looking at this one, they seem to be fairly normal, just a little few outliers that are not on top of the line here. Okay, and these ones looks fairly good to us, right? And so That is all that you need to do for your regression analysis. So if you have questions, you leave them there and we will attend to them. And let me reiterate that this is a basic course, and so if you are watching this and it's basic to you, and you think there are rooms for improvement, just let us know and we'll work on that. Thank you, and see you in another video.